Hi, everybody. So this time we're going to talk about something called pH. You've heard of pH before, but it's a pretty confusing concept. So there are things called acids and bases. Acids are common things that you might find around the home, like cola and vinegar and orange juice. And there's things like battery acid that will be very caustic, that is, burn your skin. And there are things in the house called bases, like Drano, which will clear out your pipes, which is really, really dangerous, or eggs or soap, which is very mild, but those are bases. Now, what the heck is that? Well, these are chemicals that when they are mixed with water, they produce something called either hydrogen ions, if they're an acid, or hydroxide ions, OH minus ions, if they're bases. So if you take an acid and you put it in water, it will produce more H pluses than it does OH minuses, and we call it an acid. And if you take one of these chemicals and you put it in water, it'll make more OH minuses than H pluses, and so we call it a base. So acids produce H plus ions, that's a hydrogen ion, when put in water. So we have hydrochloric acid produces H plus and a chloride ion, or sulfuric acid will also make hydroxide ions, hydrogen ions. And so those are acids. On the other hand, bases produce OH minuses. So these OH minuses, anytime you put it in solution, you make an OH minus. And you could have like sodium hydroxide, a strong base, and it makes a sodium ion and a hydroxide ion, this thing. So if it's an acid, it produces these when put in water, and if it's a base, it produces these. They can both be really, really dangerous. If you have a very high concentration of H pluses, it will burn your skin, do serious damage. If you have a whole lot of OH minuses, this is really cool. If you have a whole lot of OH minuses, they'll combine with your skin, the fats in your skin, and make soap. That's called saponification. So when the OH minuses combine with the fats in your skin, you actually turn to soap. That's the chemical reaction, how you make soap. So a solution is considered neutral, or not at all acid or base, if it produces equal numbers of H plus and OH minuses. So if you have an equal amount of OH minuses and H pluses, you're not an acid or a base, you're neutral. If you have an excess of OH minuses, you're a base. If you have an excess of H pluses, you're an acid. Now, what do you notice about OH minus and H plus? What would happen if you combined the two of those? In other words, if you had an equal amount of OH minuses and H pluses in a solution and you put them all together with each other, what would you get? Water. So water is neutral, right? It has equal amount of H plus and OH minus combined together. So here we have an acid. This is a solution that produces an excess number of H pluses. There might be an OH minus floating around, but there are so many H pluses, this would be a strong acid. This might burn you. On the other hand, you might have a solution that makes a whole lot of OH minuses. Maybe there's an H plus floating around, but basically there's a whole lot of OH minuses, and that's a base. But if you were to mix a really, really strong acid like battery acid and a really, really strong base like sodium hydroxide, and you mix them together in equal numbers, you could get this H plus and that OH minus to combine, and this one and that one and this one and that one, and they could all combine into waters, and you would just have a neutral solution. So you could take a really, really strong acid and a really, really strong base and put them together and get drinkable water, which in fact would be drinkable. Truly, it is water. It is chemically water. It's H2O. So when you get an H plus and an OH minus, at the end of the reaction, you've got simple, straightforward water that you could drink. So you could take hydrochloric acid and sodium hydroxide, both really dangerous, combine them, and you could make water and drink it. I don't recommend you do that because you have to get exactly the same number of molecules of sodium hydroxide as hydrochloric acid, so you have equal amounts of H pluses and equal amount of OH minuses, because if you get more HCl than NaOH, you're still going to have an acid. Okay, so it's a careful reaction that you would have to measure out the exact amounts so that you would have equal amounts of H pluses and OH minuses. But if you did that, if you were a very careful chemist, you could absolutely pour that solution right over your skin and it would not burn you. It would, however, have maybe some other reasons why you wouldn't drink it that I'll show you now. So here's sodium hydroxide, really strong base, produces OH minuses in solution. Here's hydrochloric acid, really strong acid, produces H pluses in solution. If you take those, you can take the OH minus and the H plus, and what do they make together? They will combine to make water. But when you do that, you're also going to still have the Na and the Cl. Remember, atoms don't just disappear into nothing in a reaction. So when you take this OH and this H and you combine it to make water, you still have the Na and the HCl in the beaker. And so you're going to have those combine, and they're going to produce something called a salt. This particular one, NaCl, is table salt. So in fact, if you took this killer sodium hydroxide and this killer hydrochloric acid and you combined them, you would make salt water, which you really shouldn't drink, but it certainly wouldn't burn you. It's completely different chemically. The water is water. It's totally neutral, totally safe. And salt's not good for you to drink for reasons we'll talk about later in the year, but it certainly is no longer an acid or a base. So when you take an acid and a base and you combine them in a neutralization reaction, that's what this is, a neutralization reaction. You take a base and an acid, you get a salt and a water. Not always the same salt. This, instead of Na, could have been K, and then you would have a salt called KCl. Potassium chloride, it's still a salt and a water. So anytime you have a base, and you combine it with an acid to neutralize, so that they neutralize each other, you get salt water. Now, I told you at the beginning of this video that we were talking about pH. Well, pH is simply a measure of how many H pluses there are, okay? So if there's a lot of H pluses or very few, you're going to measure that on the scale called the pH scale. pH measures the concentration of H pluses, and it's on a scale from 0 to 7. 0 is very, very strong acid. 14 is very, very strong base. And 7 is neutral. Okay, so 0 to 14, I think I said 0 to 7 a moment ago. The scale goes 0 to 14, 7 is neutral, 14 is a strong base, 0 is a strong acid. As you get closer and closer and closer to 7, you get weaker and weaker. So a really strong acid is going to be a pH of 1. A really weak acid is going to be a pH of 6. A really strong base is going to be a pH of 14. A really weak base is going to be a pH of 8. 7 is where you have equal numbers of H pluses and OH minuses. So we have strong acids at one end. As you move away from 7, you get stronger and stronger and stronger. Toward the 14 side, it's bases. Toward the 0 side, it's acids. And 7 is neutral. So you'll have the scale where you have all different solutions that give off different numbers of H pluses and therefore find themselves in different places on the pH scale. So the acid inside your stomach is way down here, whereas milk, very barely an acid. You can get sodium hydroxide way out here, or bleach right here, but an egg, very mild base. And that is pH.